Hi guys, welcome back. Today we're going to look at key concept 4, target 4D, the last video. Number 16 says, a fountain that is 13 feet tall sprays water into the air with an upward velocity of 9 feet per second. Write the function that gives the height h of the water in feet in t seconds after it is sprayed upward with an initial height c. There's no additional forces acting on it. And we have this vertical motion model here that we're going to use, which h of t equals negative 16t squared plus vt plus c. So we have to know here that the v right here is the velocity, and they give us the velocity. Right, and so we're just going to plug in, instead of v, we're going to plug in 9 feet. Now c is the fountain that sprays that water into the air, so how tall it is, and that would be that 13 feet tall. So that we're going to plug in for c. Everything else stays the same. So formula is still h of t is equal to negative 16t squared plus, now instead of v, we're going to write the velocity, which they give us is 9. The t stays in the problem. And then our c is plus 13. Okay, and the 9 comes from the velocity. The 13 comes from the c. The 13 feet tall, the fountain sprays the water up. 17, a rectangle has side A with an unknown length. If side B is 9 inches less than side A, create a quadratic equation that calculates the area. So area, we have to know, is length multiplied by width, length times width. And it tells us our side A, right? So I'm going to draw this rectangle here, draw around. Our side A, so one of the sides is an unknown length. So I'm just going to call side A unknown, so I'm going to call x. We'll say x inches, because we're dealing in inches. Okay, so then our side B says is 9 inches less than side A. So if side A is x, 9 inches less would mean we subtract. We're going to write x minus 9. And since that's an expression, I'll put it in parentheses. And it's in inches. So then our area, like we said over here, our area is equal to the length times the width. So our length is just x from here, and our width is this x minus 9. So we're going to multiply that by x minus 9. And area is always in inches squared. So area equals x, parenthesis, x minus 9 inches squared. 18. A ball is thrown straight up from 5 meters above the ground with a velocity of 19 meters per second. Gravity pulls it down, changing its speed by about 5 meters per second. Create a quadratic equation to model this situation. Again, we're given the vertical motion model formula, so we just need to figure out what is the v, what is the c, and plug it in. So they tell us that velocity is 19 meters per second. So instead of the v, we're going to plug in 19. And then our c value, how high above the ground, 5 meters above the ground, that's what's going to plug in for c. Excuse me. So everything else is the same. So we keep h of t is equal to negative 5t squared plus, like I said, our velocity is 19. And we still have t in that equation, plus our c value is 5. We got that from 5 meters above the ground. There is our vertical motion model equation. Number 19. A gardener is fencing in a rectangular area. He plans to enclose an area of 30 meters squared. So I'm just going to emphasize here that 30 meters squared is the area. Okay, remember area, length times width, so area is equal to 30 meters squared. I'm just going to emphasize that. Okay, he plans to enclose an area of 30 meters squared using fencing on 4 sides as shown below. So we have this nice picture here with the area in the middle, 30 meters squared. The length is 1 meter longer than the width. Part 8, let W represent the width of the rectangle area. So again, we have this W, right here's the width. If we're going to write the length, we know the length is 1 meter longer. So we're going to take this W, let me erase this. If our width is W and our length is 1 meter longer than that, our length is going to be W plus 1. Okay, and that's going to be right along here. This is our length there. Right, so B, create and solve an equation to find the width W. So we're going to have to use the idea of this area, the length, and the width to find W. Right, so just like we've seen before, we know area is equal to length times width. We're told that the area is 30, so I'm going to plug in 30 for the area. We're told that the length is W plus 1, so W plus 1, I'll put that in parentheses, and our width is just W. Okay, so now when you have this W on the outside, we need to distribute it. To distribute the W here, well, I'm going to write 30 equals, W times W is W squared. Distribute the W to the 1 plus W. 1 times W is just 1W. You could write the 1 in front if you like. Write it in there. Plus 1W. Now if we're going to solve right for W, we need to have this equation equal to 0. So in order to do that, I'm going to subtract 30 from both sides. I'm going to rewrite this up here. So 30 minus 30 is 0 equals W squared plus 1W, and then I have minus 30. Okay. Now, to solve for W, we're going to have to factor. I'm going to set up my box. When it's squared, the first box, their W squared, right here, goes in here. Our second box is the minus 30, which will go right down here. And I'm looking for two numbers that multiply the negative 30 and add to a positive 1. That positive 1 coming from that positive 1W. Okay, so what sticks out to me? Negative 30, right? You can look on your factor sheet and you will see that 5 times 6 are factors of 30. But I want to multiply to a negative 30. So I try negative 5 times a positive 6. I know that's a negative 30. If I do negative 5 plus 6, that is equal to a positive 1. And that happens to fit both of our situations. So we want negative 5W I'm going to put that in this spot here, and 6W. And now we fill out the outside. We have W and W. 6W, we have the W here, we need the 6 out here. To get the negative 5W, we need the negative 5 out here. So our two factors are W plus 6 and W minus 5. So I'm going to write that right over here. So W plus 6, and then W minus 5 is equal to 0. I'm going to set each of these equal to 0 and solve. I'm actually going to go take a step back. Do one at a time. W plus 6 equals 0. Subtract 6 on both sides, and W is equal to negative 6. If I do that for our W minus 5 factor, W minus 5 equals 0. Add 5 to both sides. We get W equals a positive 5. Now we can't have a width that's a negative length, so we can't have negative 6. So our width is going to have to be 5. W is equal to 5. And then C is to determine the length of the rectangular area. So if we know the length is W plus 1, we're just going to take our W, which is 5, and add 1 to it. So our length is equal to W plus 1. I'm just going to plug in 5 for the W. Add 1 to it, and I get 6. And we're in meters here. Is our length. All right, lastly, number 20. The combined area of the 3 window panes and frames shown below is 336 inches. We're going to change this to an area of 231 inches squared. So change that on yours now with me. Also, we're going to change that this is 3 inches, not 2, 3. So change that now. Right, and the rest of the question says, the frame is of uniform width. What is the side length x of each square window frame? Solve using any method. Okay, so that means that uniform width means if this is 3, then this is also 3 inches. All right, so we're trying to find side length x. So what I'm going to do, and I know we have area, right, and again, we know area is equal to length times width. So I'm going to set up a formula with area, length, and width. So our area we're given is 231, so I'm going to plug that in for A. We need to find our length and width. So over here, I know this little length is 3, so right here is 3. Here is x, so that means this part is x. This is x right here, so also this, and also that is x as well. So then out here, that is x. And right here would also be 3. So that all added together, 3 plus x plus 3, that entire length there would be x plus 6. And now for the width, right, we said this was 3, so that means this part down here is 3. All of this part here, we have 1, 2, 3 x's. So I'm going to call it 3x. And then this length out here is also 3. So it's that uniform width. So 3 plus 3x plus 3. This whole width here would be 3x from this 3x. Excuse me. 3 plus 3 is 6. Alright, so that is our width there. So I'm going to fill these in over here. So we have x plus 6